All right, in this video, we are going over lesson 15-1. So we just finished topic 13. We actually did topic 14 earlier in the year. That was focusing on patterns. So now we're into topic 15. And for most of you, this should be a review. We actually covered a little bit of geometry at the beginning of the school year, just to kind of revisit the third grade standards and what you should have covered in third grade on this area. So today we're going to be reviewing and revisiting lines, rays, and angles. I am on page 549 right now in your textbook. So you need to have volume 2 open and you need to make sure that you are following along. Let's take a look at this first example here. A right angle forms a square corner like the one shown below. I can see it here. We all know that. Find examples of right angles in your classroom. We're not there, so maybe in your home. Draw two angles that are open less than a right angle. So I have two things I have to do. Find some examples of right angles, then draw two that are open less than a right angle. Well, right here, just a couple of things that were handy close by when I started filming this video. The first one is a ruler. Now I can see that this angle right here forms that perfect square corner. So this is an example of a right angle. Now I could also look this way and see that this angle formed from the side of my ruler and the bottom of my ruler also forms a right angle. So that's just one household object. Another one, this is kind of funny. Oh my goodness, who is this? Rocky. Rocky's Paw Patrol dumpster, right? Recycle Rocky. I can see that these two lines right here along his truck also form a right angle. I'm not going to draw the square because Bryn would be pretty upset. But our directions were to draw two angles that are open less than a right angle. So those would be acute angles. So if the right angle opens this way, and I need to draw two that open less, I could draw something like this one. I could also draw something like that one. And it could almost be a right angle, looking very, very close. So I drew three. Let's look down here. Actually, no, we're going to skip this one. I want you to turn to the next page, page 550. Again, make sure you're following along, guys. I know this is a review. I know that. But we're going to talk about how you write these terms, which we kind of need to revisit. So a point is an exact location in space. They've given you an example right here, point Z. That's how you would label it, and that's what you would say if you were naming it, point Z. This could be like point A, point B, whatever letter you have. I think we're pretty good with this one. It's these that we need to know how to write, so how mathematicians record these. A line is a straight path of points that goes on in opposite directions. So you can see, indicated by these two arrows, that this line is going to travel forever and ever and ever in this direction and this direction. Take a look at how you record that. You have the line with both arrows, and then you include both endpoints that are here. This is line A, B. Now, what about a line segment? Well, a line segment's almost like you have a line that's going on and on and on and on forever, and you just take out a small chunk of it. And so you have two endpoints, and again, it's just part of a line. So I can see the two endpoints. There are no arrows. Segment means like part, so it's a line part. Again, how you record this, take a look. It's just a straight line. You would read this line segment GR. Now a ray has one endpoint and continues on and on in one direction. So how you would record that would be an arrow going in one direction with ray NP. So you include both of those endpoints. Now let's take a look. We're going to quickly revisit angles. So we know that a right angle forms the square corner. We've said that probably 95 times. And how do you label an angle? Well, usually they are named with three letters. They have a shared endpoint. For example, this shared endpoint is point B. And now how they name them, they use the other two endpoints with the endpoint in the middle. So this is angle A, B, C. You can see how it's recorded right here. This is angle DEF. And I can see that it opens up less than a right angle, so this is an acute angle. So cute. When I look at this angle, again, the shared endpoint is right here, point H, so this is GHI, and this opens up greater or larger than that dashed line right there, which indicates a right angle. Because it opens up bigger than that right angle, this is an obtuse angle. Last one. This is an example of a straight angle. Why? Because it forms a straight line. It continues on, and here's the shared endpoint right here in the middle. So this is angle JKL. And again, it is a straight angle. And many of you already know this, but this is equal to 180 degrees. Let's take a look down here at the bottom on page 550. We have to complete each figure to show the given angle. So an obtuse angle. You could draw this two ways. Maybe you want to draw it going up this way, but also recognize that an obtuse angle could also be drawn this way, so going down. Both showing that they're open greater than a 90-degree angle. A straight angle, the only way you can do this one is to keep on going in this direction. An acute angle, again, maybe it can look close to a 90-degree angle. And also, acute angles don't have to go just in one direction. They can go in many different directions. So, keeping in mind the same thing as the obtuse. The right angle, again, forms a right angle forms a square corner, sorry. It can go this way, but also recognize that it can go, whoops. That's what I meant to do. So pointing down. I know, kind of silly. You guys already know this stuff. Let's look at page 551. Now we get into the good stuff. Naming some of these. So what geometric term describes a part of a line that has one endpoint? Draw an example. Well, if you have one endpoint and then part of a line, this is a ray. Now, if I want to draw an example, maybe I'll name this ray QR. What geometric term describes part of a line that has two endpoints? Draw an example. Two endpoints that are part of a line. Well, it's not continuing on, so this would be a line segment. And I could label this like CD. Let's look at number 3. Which geometric term describes an angle that forms a square corner? Oh my goodness, I feel like we've said this so many times. It is a right angle. All right, numbers 4 through 7. Use geometric terms to describe what is shown. Well, this does not travel on in both directions. It has two endpoints and it stops right here and here. So this is a line segment. And if I wanted to name it, remember it would just be a line straight above and then P and X. If it were a line, it would have those arrows. This one I can see is a right angle. And if I want to name it, because they've given me the points, it would be angle PQR. PQR. Again, the endpoint that they share must be in the middle. All right, number 6. I can see one endpoint and then it's part of a line that travels on and on and on forever in one direction. So this is an example of a ray. And if we want to write it the correct way, this would be ray BY. Last one. This is clearly an angle. It is smaller than a right angle. It is an acute angle. And if I want to name it, that would be angle LMN. Excellent. You guys have some practice problems. You're doing 8 through 15 on page 551, and then you're going to turn it over. You have some word problems you're going to solve, 16 through 20, and you do have an exit ticket. We'll meet at 2 o'clock to go over these.